I welcome you all to the Spark Research YouTube channel. This is Dr. Virchandra, assistant professor in the Department of ECE. And in this session, we are going to take the contents from this analog and digital communication course. And this is the session where we are going to cover this unit 4 passband transmission system. So this is the first part, and shortly we'll come with another parts, and so that will be the concluding parts, right? So we'll have the only two parts for this unit. So in this unit we are going to focus the passband transmission system model, passband modulation techniques, and the signal space diagram along with the detection, right? So let's see the details. Here is the syllabus for your fourth unit. Apart from this passband modulation transmission system, we have to learn the probability of error in all these type of the modulation techniques. So in this session we will see only this password type of the modulation transmission system, and error we will look into the another parts. So first question is that what is this password transmission system? So password transmission system is a communication system in which the baseband signal is modulated, right? So baseband, like there are the two type of the transmission system, baseband and passband. Baseband means no need to modulate, that is called baseband, and passband means you are using the higher frequency for modulating, so that is the passband into a high frequency carrier for a transmission channel, right? So where is it used? So wireless communication system, of course this is the passband communication, and baseband like your Bluetooth type of the communication where directly you are using, right? No need to modulate. So passband, your information source is here, and then baseband, that is empty, like empty itself, and also like suppose if you are using mic na, like amplifier type of the mic, that is the best example of your baseband, means without modulating you are sending. And here your model here we are using the passband, means the some another frequency, higher frequency, right? So modulating and then send to this transmission channel, and at the end of the receiver definitely you have to use the demodulator. Okay, so transmitted signal st is mt cos omega ct. This is for passband only. The received signal your st and plus nt, and demodulated you are going to receive the m of t, right? So these are your the key points that you can remember. So whenever we are sending the digital or an analog signal, we are going to encode the information, and at the end of the detector you have to also decode, right? So this is the modulating onto an analog, and so this is how you can modulate the information and demodulate, right, into the digital stream. Okay, so digital signal transmission, here if you look into the what type of the transmission, actually mostly we are talking about this transmission technique, right? So here basically two types of the transmission of digital signals are there. One is your baseband and one is your passband. Already we have discussed. So here now you can check the differences. So digital data is transmitted over channel directly, right? So whatever the data you have directly you are sending. In baseband no need to modulate. In passband you have to use a modulation technique with a high carrier frequency. So this is the major difference, right? And then of course no modulation is required. Modulation is required then suitable for transmission for only you can send it to the lower distance, right? Longer distance you cannot send. For longer distance you have to use the the transmission channel. Then easy example is your audio video signal, and ASK, FSK, PSK, these are the major parts of this the terrestrial transmission system. So we are going to focus on these three things, ASK, FSK and PSK, in our upcoming sessions. Okay, so let's start. So requirements, why is it required? So maximum data transmission rate is it will have, then probability of error will be the minimum transmitted power is required here. So minimum channel bandwidth is also used. So maximum resistance to the interfacing signal, minimum circuit complexity. so much more required, right? Advantage of your password, multiple advantage: long distance communication, analog channels can be used for transmission, multiplexing techniques can be used for bandwidth conversion, and more problems ISI and crosstalk may be the reduced, not absent, it's reduced. Then password transmission can take place over the wireless channel also, right? So actually, this is the just background whenever we are going to talk about the password, that is ASK, FSK, and PSK, right? So why are we talking about all these ASK, PSK, FSK, right? Modulation techniques. So this is just the background. You can check these, like what are the advantage, disadvantage, all these things, right? Okay, so now let's start these modulation technique, right? Digital password transmission system. So suppose your data streams are 0, 0, 1, 1, 0. Suppose these are the data. So how will you send these information 0, 0, 1, 1, 0, 1, 0? And what are these 1, 0? Of course, all of you are aware this is nothing the voltage. So high, low, low, high, high, then low, high, something like that. Okay. So there are the three different techniques we are going to use. So first technique is the called amplitude shifting. These are the, remember, these are the modulation technique in digital transmission system, right? If you remember in analog, then we have used the what is called your delta modulation and not what is called like amplitude modulation, frequency modulation, phase modulation we have used. So here also relative, the comparatively it's a very equivalent to that. So amplitude shifting very equivalent to the your amplitude modulation, then frequency modulation, this one, then phase modulation. So this is very much related to that, but only thing is that here we are using shift keying because shift keying is being used because this is your digital transmission. So here we are going to use the key in order to shift your amplitude or shift your frequency or shift your transmission, right? So here you can just check here. For 0 signal your amplitude is what? Nothing. 0. For 1, like what is the amplitude? Amplitude is like higher, right? Again 0 means no amplitude, 1 means the amplitude. So signal is present or not, so like that you can send the amplitude shift keying. Similarly for FSK, that is for frequency shift keying, here if 0 is there now, you can check corresponding to 0 frequency is less, right? And corresponding to 1, what is there, frequency is very high, right? So this is the difference. So f1 is for 0 and f2 is for 1. So similarly you can send the information using the FSK. Similarly for phase modulation, now if you will check now, for 0, 0 there is a one phase, and for 1, 1 here you can check the another phase, right? So phase is shifting by how much? Pi by 2 here, pi, no? The 180. Again phase is shifting here also, phase is shifting here also. So whenever you are transmitting from 0 to 1 or 1 to 0, the phase is shifting, right? So here see 0 to 1, so phase is shifting. So this is the basic concept behind the ASK, FSK, and PSK, right? So I hope you remember. So major things that in ASK amplitude will vary, in FSK your frequency will vary, in PSK phase will vary. Okay, very similar to the amplitude modulation. So we'll see in the some more details. So amplitude shift keying. So this is your amplitude shift keying is a digital passband modulation technique in which the amplitude of the carrier signal changes according to the binary data, right? So here amplitude of your carrier signal is going to vary. So this is the important, right? While the frequency and the phase will be constant. So example, already we have seen amplitude is 0 here and amplitude is changing, right? So what will be the amplitude? So for binary 1a your signal is a cos omega ct, and for binary 0 you are sending nothing, right? Similarly here is your ASK generation. So how will you generate? So digital data stream will be the inputs, like combination of 0, 1, 0, 1, all these, and the carrier signals that will be, that will cause to generate the higher frequency, finally product multiplier, and then you can send the data, right? Okay, so FSK, that is frequency shift keying. FSK is a digital modulation technique in which the frequency of carrier signal changes according to the binary data, right? So here what is the measure points? Measure point is the carrier signal changes according to the binary data. So this one is the here the frequency of the carrier, right? So frequency is keep on changing while the amplitude and the phase will constant, right? So here see f1 is here and f2 is here. So this is your f2 and f1. So these are the differences. So you know that if you are sending 1, then you are using f1. Like if you are sending 0, you are using f2. So this is the major difference. How will you generate FSK? So exactly you can use the VCO, that is voltage controlled rectifier oscillator, and using this you know that you can generate the FSK type of the signals. Phase shift keying. So phase shift keying is a digital modulation technique in which the phase of the receiver, right? So here phase of the carrier signal is changing according to the binary data. So this is the crux, right? So while the amplitude and frequency, of course, it will be constant, and here you can check the frequency here. So phase is your nothing is here. So this is for 1, like this is for 1. So phase is 0, and for binary 0, you can check here phase is shifted by pi. So here you can check phase is shifting from 1 to 0, right? So this is the major difference. So likewise, you can draw the graph for ASK phase. And PSK you can generate using this phase shifter for quadrature. QPSK also you can generate. For BPSK you can also generate plus minus pi, right? Like that. Signal space diagram, actually this will tell you about the the very easy to find out the number of the the how many bits we are using. So suppose one bit means either we'll have the 0 and 1, and so ASK amplitude is there on the x-axis, and for FSK the frequencies are there, and for PSK your angle is there on the x-axis. So you can see that angle is the difference is 180. So this is very easy to get the information from about the signal, right? So especially these graphs are being used to calculate the probability of error, so that we will look into the later. But the signal space diagram is a very shortcut technique which is the used in the digital communication to represent the different signals as point only in a geometrical space. So this will help you to find out the error of the probability. ASK detection. Now detection, how will you detect? So like for non-coherent technique, mostly we are going to use envelope type of the detector, and then of course the decision making is there. So demodulation of the digital modulated signal is similar to that of the analog modulation signal, right? Like ASK here you can see. So can be demodulated coherently or non-coherently. So coherently, in that case you need the filter, and it will be synchronous, and non-coherently definitely you need the envelope detection. So the coherent detector requires more elaborate equipments and has superior performance, especially when the signal power is low. So coherent detection is a little bit difficult. However, the non-coherent technique is easy. Okay, so FSK, now how will you detect non-coherently? So non-coherent detection is used when the receiver does not require phase synchronization with carrier signal. So the received signal is applied to the band pass filter in that case. So here you can see the lower one is your coherent detection. So here we are using the low pass filter and then compare, and the top one, this one is your non-coherent detection. So here we are using the envelope detector and then comparator. Comparator is why are we using? It will compare the data whether is this belongs to the 1 or 0 with the help of the certain voltage. So coherent detection provides, of course, the better accuracy, but it requires the exact knowledge of the carrier frequency and phase. Then only we can synchronize, right? Because synchronization is a challenge in the coherent detection. So the receiver generates two local reference signals that match the transmitted carrier frequency omega c0 and omega c1. So the received signal is split into two branches and applied to two multipliers. Each branch multiplies the received signal with one of the reference signal. So here is your PSK detection block diagram. So PSK signals may also be demodulated non-coherently as well using an indigenous method of the differentially coherent PSK. So these are related to the non-coherent detection, right? So here if you see signal is there, product multiplier is there, local carrier oscillator is there, and then filter will be used. And suppose this is coherent, then in that case you did not require to use the filter, use the envelope type of the detector for coherent. So don't get confused in between the coherent and non-coherent, right? Now here is the some details about the QAM. QAM is nothing quadrature amplitude modulation, the combination of the two things. What are that? Amplitude modulation and phase modulation, using two carriers that have the 90-degree out of the phase here, right? How will you generate? So here is your generation techniques, your the phase difference that you are going to give, then frequency is already you are going to use, that is omega ct carrier frequency. So that will give you the QAM type of the results. So in the detector side, again local oscillator will be used, phase shifter will also be used, and then low pass filter for coherent detection, right? Signal space diagram you can see here for QAM side, like here phase is there and amplitude is on the y-axis. So here the point is representing the number of the signals that we are using. So here like this is not the binary, here 4 4 4 total 16 signals are there. So that we can increase the number of signals using the QAM technique, right? The combination of the amplitude and phase modulation. So that is why this is the better one, because you can increase the bandwidth. We can increase the transmission rate further by using, so that is the target. So you can check that this the QAM is one of the important. Okay, that's all in this session. Thank you to join. If you have any doubt, please drop your comments and we'll shortly come with another parts of this unit 4, right? Thank you.